Hi, this is Rick and Molly.
I'm Rick.
And I'm Molly. And we answered your tough questions.
I have a tough question for you, Molly.
Okay, what's your question?
Can we time travel?
No, but we can almost stop time. Thank you for joining us on Rick and Molly and for our talk about time travel.
Now, earlier you mentioned that there are some ways that you can slow down and possibly even come close to stopping time. What are those ways?
Well, the first way is by traveling near or at the speed of light, because it will slow down time. Some of the proof that NASA has gotten is by shooting off satellites around the Earth that are going very fast, and as they go around the Earth, they put a clock on those satellites, and the clock was actually going faster than the clock on Earth, even though they set the clock that went on the satellite at the same time as Earth time.
Was that clock going faster or was it going slower?
It was going slower.
There we go. And so if we went fast enough, we could almost stop time completely then, couldn't we?
Yes, we could.
What was the other way that you said it was possible?
The other way is by going near an object with mass.
What are some objects that have lots of mass?
The sun, the Earth, a black hole, definitely.
Those all have lots of mass.
And there is no proven way that we can stop time, but there are ways that we could slow it down.
All right. So by going next to something with lots of mass, have we ever seen that slow down time?
Yes.
We have?
Mm-hmm.
How did we see that one?
We saw it with Mercury circling the sun. Because of the mass, it slowed Mercury down.
So in other words, when we looked at Mercury, it looked like it was going in slow motion?
Yes.
Oh, well, that's pretty crazy.
Mm-hmm. It's crazy.
All right, well, let's use our sketch tool and see if we can explain some of those to our viewers.
Okay. Okay, so we are going to be drawing light speed first. So we are going to be drawing the satellite going around the Earth and the big fat sun.
Well, I was thinking, how about we do Molly and Bolly?
Oh, Molly and Bolly.
Oh, Molly.
Bolly's my twin sister.
She's our imaginary twin sister that we use to help explain some of this. So first, let's just draw the sun out here, just because it's good to have a sun in the picture, right? Okay.
Yes.
All right. So now we're going to draw our blue marble Earth right somewhere around here.
Yep, because Earth is a marble.
All right. So let's say we have Molly, who lives on Earth, right? And she's 10 years old. Okay. Now let's say Molly has a twin sister named Bolly. Let's say
who's also 10 years old.
Yeah, also 10 years old. We like to make her red just so we can tell them apart. Okay. So let's say that Bolly got on a spaceship and she traveled way out in space and traveled back. And let's say she traveled near the speed of light. And let's say it took her 10 years to make this, or here, just for the sake of math, let's say that she traveled at almost right at the speed of light. So, after 10 years went by and she finally got back, you want to know what the interesting thing would be?
Bolly would still be 10, but Molly would be 20.
And for Bolly, the time would appear to have
never have happened.
Right, but Molly would have experienced all those 10 years. So now let's move on to the other one in which we have a lot of mass. So let's say we
have the sun.
Do you want to do the sun or do you want to do a black hole?
A black hole.
Let's do a black hole, all right? So in the middle of our galaxy, and in the middle of most galaxies, is a giant black hole.
That's what creates a galaxy, because it gets all the, whatchamacallit?
The stars.
The stars.
Yeah. So let's say
In the
Earth.
solar systems. And it crunches them all together.
Little blue dots circling around this black hole. Well, actually, and let's draw our sun too. It'll be a bigger dot. Alrighty. And we still have Molly living on Earth here.
That somehow I stand on.
Somehow, very carefully. Alright. Now let's draw that same spaceship here, right? Okay. And this time she doesn't travel at the speed of light. Let's say she travels at just regular speeds. But in this situation, her path has her go right next to a black hole and back. Now, what would happen to her time in this one?
It would stop.
It would stop.
Because the black hole has so much mass that it would stop time.
So in this experiment, just like before when she was going that near the speed of light, Molly, if this took her 10 years to make this trip, Molly would be 20, but her twin sister, Bolly,
she'd be 10.
Still be 10. And those are the methods that we have observed to be true when it comes to time travel.
And on a related-ish note, if you ever get stuck in a black hole, you need to use its force against it by going into it and getting it to fling you out.
So use the black hole's own gravity to get you out, much like Bolly did right here, when instead of hitting the black hole, she just missed it so that she could come back to Earth.
And if you're ever going to go around, instead of trying to get out of the black hole, you should try going up or down so you barely miss it and you get flinged around. Well, this was Molly and
Rick.
And just thank you guys for watching the video, and please leave a like in the description below. And any other questions you have, please leave them in the comments. And just subscribe and like, and thank you guys for watching, and bye!
Bye.